Ever wondered what could happen if we could manipulate matter at an atomic level? Welcome to the world of the infinitesimally small, where science fiction meets reality. This is the world of nanotechnology, a field that's all about manipulating matter on the nanoscale. To understand just how tiny we're talking, let's consider this. A single nanometer is 1/1,000,000th of a meter. That's roughly 10 times the diameter of a hydrogen atom, or 100,000 times smaller than the width of a human hair. In the world of the ultra-small, we're not just dealing with a few atoms. We're manipulating, moving, and even creating materials atom by atom. Now, you might be wondering, is this just theoretical, or are nanotechnologies already part of our lives? You'd be surprised. Nanotechnology is not just a concept for the future, it's already here, embedded in our everyday lives. Take a moment to consider the sunscreen you slather on during those hot summer days. Many sunscreens contain nanoparticles of zinc oxide or titanium dioxide, which provide better protection against harmful UV rays than their larger particle counterparts. Or consider the scratch-resistant coatings on your eyeglasses, car, or even your favorite electronic devices. These coatings often contain nanoparticles that provide increased durability and longevity. These are just a few examples of how nanotechnology is already making a difference. It's not just about making things smaller, it's about making things better, more efficient, and more effective. But like any powerful technology, with great potential comes great responsibility. As we continue to push the boundaries of what's possible on the nanoscale, it's crucial to consider the ethical and environmental implications. So now that we know a bit about nanotechnology, let's dive into its potential benefits. The world of the ultra-small has a lot to offer, and we're just beginning to scratch the surface. Stay tuned as we delve deeper into this fascinating field, unraveling the nano-mystery one atom at a time. Imagine a world where diseases can be detected and treated even before they manifest symptoms. This isn't a line from a science fiction novel, but a potential reality with the advent of nanotechnology. Let's delve into the nano potential, focusing on 3 key areas: medicine, materials, science, and electronics. In the realm of medicine, nanotechnology could rewrite the rules. Picture nanoparticles, so small that they can navigate through our bloodstream. These could be engineered to deliver drugs directly to ailing cells like guided missiles. This targeted drug delivery could increase the effectiveness of treatments, reduce side effects, and potentially even eliminate diseases at their earliest stages. Furthermore, nanosensors could be deployed in the body to detect diseases before symptoms appear. They could alert us to the first signs of trouble, like cancer cells multiplying or blood sugar levels rising, giving us a fighting chance to intervene early and decisively. Next, let's turn to material science. Here, nanotechnology could create materials that are lighter yet stronger than anything we've seen. Imagine airplanes made of nano-enhanced materials that are so light and robust that they drastically reduce fuel consumption. Or consider a world where bridges and skyscrapers are constructed with nano-reinforced steel, making them more resilient to natural disasters. Finally, in the arena of electronics, nanotechnology could be a game-changer. By shrinking electronic components down to the nanoscale, we could create devices that are faster, smaller, and more powerful. Your smartphone could become as powerful as today's most advanced supercomputers, fitting not just in your pocket, but on the tip of your finger. The possibilities seem straight out of a sci-fi movie, but they're not. They're here, in the realm of the infinitesimally small, the domain of nanotechnology. Yet, as with any revolutionary technology, there's a flip side. As impressive as these benefits sound, we must also consider the risks associated with nanotechnology. But what if these tiny particles could also cause harm? As we marvel at the potential of nanotechnology, it's crucial not to overlook the potential risks associated with it. Let's delve into the health concerns first. Nanoparticles, being so small, can easily infiltrate our bodies, penetrating our skin, eyes, and respiratory systems. Their tiny size also allows them to pass through the blood-brain barrier, a protective shield that prevents harmful substances from entering our brains. Now imagine what could happen if these particles were toxic or carried harmful substances. The long-term effects on our bodies are largely unknown, and that's a cause for concern. Then, there's the environment to consider. The production, usage, and disposal of nanomaterials could lead to nanoparticle pollution. These particles could contaminate our air, water, and soil, potentially wreaking havoc on ecosystems. Plus, we're not entirely sure how these particles might interact with various biological systems in the environment. We're essentially navigating uncharted territory here. And then, there's the gray goo scenario. It sounds like something from a science fiction novel, but it's a legitimate concern in the field of nanotechnology. The idea is that self-replicating nanobots, designed to perform specific tasks, might get out of control and start to consume everything in their path to create more of themselves. It's a worst-case scenario, of course, but it's a risk we need to consider as we venture further into the nanoworld. However, it's essential to bear in mind that these risks aren't necessarily a reason to halt progress. Instead, they underscore the need for careful, responsible research and development. We've faced similar challenges with other technological advancements in the past, and we've managed to navigate them successfully. While the risks are real, it's important to remember that every technological advancement comes with its own set of challenges. Our task, as we continue to explore the nano frontier, is to balance the promise of nanotechnology with the potential perils, ensuring we harness its power for the greater good. So, how do we find the balance between the potential of nanotechnology and its risks? This question is crucial as we navigate the nano frontiers. The answer lies in three key areas: regulation, research, and public discourse. Regulation is an essential tool in managing the risks associated with nanotechnology. Government bodies worldwide need to establish guidelines to ensure the safe development and use of nanotech. These regulations should be flexible enough to accommodate scientific advancements, yet stringent enough to protect against potential hazards. However, regulation alone is not enough. It must be grounded in thorough and ongoing research. Scientists play a critical role in this. They are the ones pushing the boundaries of nanotechnology, and they are also best positioned to understand and predict its risks. By conducting rigorous studies and sharing their findings with the world, they can help us make informed decisions about how to use nanotech responsibly. Yet the conversation shouldn't stop at the laboratory door. Public discourse is a vital part of managing nanotech risks. After all, the impacts of nanotechnology will be felt by all of us. Therefore, it's essential that everyone has a say in how it's used. This means fostering open and accessible conversations about nanotechnology. It means educating the public about what nanotech is, what it can do, and what its potential risks are. The role of the government, scientists, and the public in this process is interconnected. Government regulations should be informed by scientific research, which in turn should be guided by public concerns and interests. And the public should be educated and empowered to participate in the discourse, helping to shape the direction of nanotech development. This balance isn't just about mitigating risks. It's about ensuring that the incredible potential of nanotechnology is realized in a way that benefits us all. It's about making sure that as we explore the nano world, we do so responsibly and ethically. Indeed, the future of nanotechnology will be shaped by how well we manage these risks. So, what does the future hold for nanotechnology? As we peer into the nano future, the horizon is filled with possibilities. Nanotechnology, a field that is as small as 1/1,000,000th of a meter, promises to bring about a paradigm shift in sectors as diverse as medicine, electronics, and materials science. In the realm of medicine, scientists are exploring nano-robots that could travel through our bloodstreams, diagnosing diseases and delivering targeted treatments. Imagine a world where cancer cells are eradicated without causing any harm to the surrounding healthy tissues. We're not quite there yet, but the future looks promising. In the sphere of electronics, one can envision a future where nanotechnology enables the production of smaller, faster, and more energy-efficient devices. The advent of nanochips could revolutionize computing, with quantum computers becoming a household name. And let's not forget materials science. Nanotechnology could lead to the development of ultra-strong, lightweight materials. Products could be made more durable, more efficient, and more environmentally friendly. Imagine solar panels that are so efficient that they can power an entire city, or a car that is so light yet so strong that it consumes less fuel and emits fewer emissions. But let's remember, with great power comes great responsibility. As we continue to unlock the potential of nanotechnology, we must also consider the ethical and environmental implications of our actions. We need to ensure that nanotech developments are carried out responsibly, with a keen eye on their impact on our society and our planet. As we look ahead, the future of nanotechnology is exciting, filled with potential, and brimming with opportunities. It's a new frontier, a microscopic world that holds the key to solving some of our biggest challenges. But like all scientific advancements, it's a journey that needs to be navigated with care, forethought, and a deep understanding of its implications. We need to strike a balance between exploration and exploitation, between risk and reward, between innovation and regulation. In the world of nanotechnology, we're only limited by the boundaries of our imagination. So, let's keep exploring.